हेलो स्टूडेंट्स, वेलकम टू गणेश अकेडमी। आज हम सॉल्व करने वाले हैं भारतीय विद्यापीठ की क्वेश्चन बैंक फॉर इंजीनियरिंग मैकेनिक्स सब्जेक्ट। राइट, सो स्टार्ट करते हैं फर्स्ट क्वेश्चन से। अ सपोर्ट ब्लॉक इज एक्टेड अपॉन बाय टू फोर्सेस एज शोन इन फिगर। सो दिस इज द फिगर। Knowing that the coefficient of friction between the block and inclined plane, actually it is inclined plane, is mu s is equal to 0.35. Then determine the force P required to start the block moving up the plane. So exactly क्या करना है, horizontal force find करना है P which is applied on the block to move this block in this direction. So this is the direction of motion mentioned. Okay. So what is given? Mu is given 0.35, and from diagram you can say the weight of the block is 800 Newton. Okay, and the angle of inclination you can take any angle, let's say theta. That angle with the horizontal is 25 degree. Okay, so to find is the force P and to start the block moving up the plane. So this is important. Okay, so हमें find करना है force P ये block को move इस डायरेक्शन में करने के लिए। ओके, सो फर्स्ट ऑफ ऑल हमें आइडेंटिफाई करना है व्हाट आर द फोर्सेस इन्वॉल्व्ड इन दिस पर्टिकुलर केस। तो एक है 800 न्यूटन, एक है अप्लाइड फोर्स P, एंड देयर विल बी रिएक्शन इन द नॉर्मल डायरेक्शन, राइट, एंड एज दिस इज द direction of motion, this is the direction of motion, there will be force in the opposite direction. If this is normal reaction n, then this is mu s into n, and हमें find करना है just to start the motion what is the amount of force P required. So this is a case of impending motion. About to start the motion जो रहेगा that certain amount of force P we need to find. यहाँ पे find क्या करना है, P force. So to find is P. तो यहाँ पे हमें फ्रिक्शन कॉन्सेप्ट यूज होने वाला है। इक्विलिब्रियम चैप्टर में जो फ्रिक्शन पार्ट आता है वो है, राइट। सो अभी हम ड्रॉ करेंगे इसका एफपीडी एंड देन वी कैन इजीली अप्लाई द कंडीशंस इन ऑर्डर टू गेट दिस P force required. Okay, यहाँ पे एक इंक्लाइंड प्लेन है 25 डिग्री, and there is one block, okay, on the inclined plane. Now there are forces. One is force P applied horizontally. So as given, it is applied horizontally. Then the weight of the block will be acting in which direction? Particularly downward direction. It is equal to 800 Newton. Okay, so direction of motion is this. impending motion केस, तो जो frictional force रहेगा that will be in the opposite direction, and that is equal to mu s into n, where n is the normal reaction. Okay, at the surface. So here it is n. This is the frictional force F, you can say. अब हमें क्या फाइंड करना है, यहाँ पे रिजोल्यूशन करना है फोर्सेस का P एंड 800 न्यूटन. So for our convenience, we are going to resolve these forces in the plane and perpendicular to the plane, this inclined plane. These are components of weight, and in the same way, these are components of this force P. So this P force. So we need to find first angle. तो ये 25 डिग्री है. So this angle should be 25. यहाँ पे ये जो हम ट्राइंगल बनेगा ये 90 डिग्री एंगल है, right? And the angle, this angle will become 90 minus 25, and ultimately you will get to know this angle is 25. So ये जो एंगल है, यहाँ से हमें पता चलेगा जो वेट का कंपोनेंट है ये रहेगा वेट का कंपोनेंट W sin 25, and this is going to be W cos 25. Where this is W 800, and ये जो फोर्स रहेगा ये एंगल बनेगा 25. तो ये जो रहेगा ये फोर्स रहेगा P cos 25, एंड ये जो रहेगा P sin 25. ओके, सो फॉर आवर कन्वीनियंस हम क्या करेंगे, ये जो इंक्लाइन प्लेन है इसमें हम रेफरेंस एक्सिस कंसीडर करेंगे. एक्स एक्स एंड वाई वाई एक्सिस. ओके, सो बहुत सारे फोर्सेस इन्वॉल्व है, हमें उसको कंडीशंस ऑफ इक्विलिब्रियम अप्लाई करना है. ओके, सो फर्स्ट फॉर इम्पेंडिंग मोशन we can apply the conditions of equilibrium. Let's say summation of forces along y is equal to 0. तो ये जो forces है along y axis वो consider करने हैं. तो we are going to assume this as positive and this as negative side, this as positive and this as negative side. तो ये n पॉजिटिव, वेट का जो कंपोनेंट है दैट इज W cos 25, downward direction, negative direction, where weight is 800, or you can just write weight cos 25. Then दूसरा है P sin 25. Okay, where we know only weight, so 800 cos 25. P is also unknown, P sin 25 is equal to 0. यहाँ पे 800 cos 25 725.046 minus P sin 25. So I can rewrite this equation as n minus P sin 25 is equal to positive 725.046 and equation 1. And same way, summation of f of x, that means forces along x axis. So W sin 25, P cos 25, and this frictional resistance or friction force F. So this is towards right, positive direction, W sin 25, then minus P cos 25, and then F positive, where this is 800, P is unknown, and F is mu into N, where mu is 0.35. Into N. So rewriting this equation, 0.35 N minus P cos 25, and this 800 sin 25 we can write here on the right hand side as minus 800 sin 25. So now solving those equations simultaneously, 1 and 2, we'll get to know the value of P. Where first equation is n minus P sin 25 is equal to 725.046 and another equation is 0.35 n minus P cos 25, that is equal to minus 800 sin 25, equation 2. So solve these two equations. So after solving these equations, first unknown, which is N, normal reaction is 1054.864 Newton, and the force P is 780.416 Newton. Okay, which is mentioned in your question bank 780.42. Okay, तो सिंपली हमने क्या अप्लाई किया, डिपेंडिंग अपॉन द डायरेक्शन ऑफ मोशन फ्रिक्शनल फोर्स अप्लाई किया, एंड हमने अप्लाई किया कंडीशन फॉर इम्पेंडिंग मोशन, इक्विलिब्रियम कंडीशन, जो भी फोर्सेस है उनके लिए कंडीशंस ऑफ इक्विलिब्रियम अप्लाई करके फाइंड किया अमाउंट ऑफ फोर्स पी रिक्वायर्ड जस्ट टू स्टार्ट द motion of the block in this up direction. Okay, so just to avoid confusion मैंने यहाँ पे न्यूटन का पूरा लिखा है, बिकॉज एन हमने नोटेशन यूज किया है नॉर्मल रिएक्शन के लिए. ओके, तो स्टार्ट करते हैं सेकंड न्यूमेरिकल. यूनिफॉर्म लैडर 100 न्यूटन एंड 5 meters long has lower end B resting on the ground and upper end A is resting against a vertical wall as shown in figure. So this is the figure given. Ladder AB resting against the wall and on the floor. The inclination of the ladder with the horizontal is 60 degree and the coefficient, if coefficient of friction of at all surface of contact, that means at wall as well as at floor, is 0.25. They determine how much distance up along the ladder a man weighing 600 Newton can ascend without causing it to slip. So they are asking us to calculate the distance D, right, from let's say B end. Okay, so what is given? Okay, given है weight of ladder is given, then length of ladder is 5 meters, coefficient of friction at all surface 0.25, angle of inclination let's say theta is 60 degree, and the weight of man is 600 Newton. Okay, so first of all हम फाइंड करेंगे कौन से फोर्सेस एक्ट हो रहे हैं. So what are the various forces acting on the ladder, and then we can easily use the FBD to find this distance. So here normal reaction at B, यहाँ पे एक normal reaction act होगा, यहाँ पे एक normal reaction act होगा, and then in the direction of motion, let's say direction of motion without causing it to slip means इसका motion towards right होगा, इसका motion down direction होगा, तो opposite to that direction क्या act होगा, frictional force resistance mu into normal reaction, that is Na here, and here mu into Nb. Okay, then at the center of the ladder, let's say this point C, the weight is supposed to act in the vertically downward direction, and at this particular point the weight of the man is acting, right. तो अब हम ये जो लैडर है इसका FBD ड्रॉ करेंगे एंड देन वी कैन यूज द कंडीशंस ऑफ इक्विलिब्रियम टू एनालाइज एंड टू फाइंड द डिस्टेंस D. Normal reaction NB, frictional resistance mu into NB, that means 0.25 into NB Na 0.25 Na. Then at center C, weight 100 Newton of the ladder is acting, and let's say at distance T, weight of man, let's say W1, 600 Newton is acting. Okay. So इसका जो लाइन ऑफ एक्शन है, राइट, या हमें डिस्टेंसेस फाइंड करना है. In the same way, this distance, knowing that this angle is 60 degree and the length of the ladder L equal to 5 meter. So if this angle is 60 degree, this hypotenuse of the right angle triangle is 5, then you will get to know that this distance should be 5 sine 60 and this entire distance is 5 cos 60. Now take this smaller right angle triangle, this distance C is the center, that means BC is 2.5. So this should be 2.5 cos 60, and if this is hypotenuse of the smaller triangle D, then this should be D cos 60. Okay, now apply conditions of equilibrium. Well, first let's say summation of vertical forces. So this 0.25 Na upward positive, NB upward positive, and 100 and 600 downward negative. So 0.25 Na plus NB minus 100 minus 600 is equal to 0. So 0.25 NB Na plus NB is equal to 700. Right? Equation 1. In second, another equation, summation of horizontal force. Na towards right, then NB towards left. So Na towards right positive, 0.25, NB towards left negative. Now we have two equations in terms of Na and NB. We can solve those for value of Na and NB simultaneously. So solving equation 1 and 2. We'll get Na and NB. 164.705 Newton and 658.82 Newton. Okay, and now apply condition that moment about B is equal to 0. So in order to get the distance T, so at this particular point moment at B for NB and 0.25 NB forces is 0. So ultimately we'll get moment for W1 100 and 0.25 and NA. So I am assuming here as anti-clockwise positive, clockwise negative. So the sense of these both NA is clockwise, for 0.25 NA is also clockwise, and for these 100 and 600 forces is anti-clockwise in sense about B. So minus NA into, which is equal to NA we have value 164.705 and 658.82 NB. So minus 164.705 into perpendicular distance from moment center B is 5 sin 60. Then for this 0.25 NA perpendicular distance is 5 cos 60. Anti-clockwise sense, clockwise rotation or clockwise sense, so negative. So 0.25 NA is 164.705 into distance, distance is 5 cos 60. Then for this 100 Newton perpendicular distance is 2.5 cos 60, and for this 600 Newton this is perpendicular distance d cos 60, and anti-clockwise sense, that means negative, positive. So 100 into 2.5 cos 60 and 600 into d cos 60. We can solve this for value of D. So for first three terms we have answer minus 691.134. Then 600 into cos 60 is 300. So you'll get to know that value of D as 691.134 divided by 300, 2.304 you can write meter. Okay, this is the distance of a man he can ascend without causing the ladder to slip. Okay, so So just apply the conditions of equilibrium, right, for the impending motion case. Next, okay, third question is on the kinematics topic. The motion of a particle moving in a straight line is given by the expression S is equal to, so expression is given, displacement, right, plus 2t plus 5, where S is the displacement in meter and t is the time in seconds. Determine the velocity and acceleration after 4 seconds. So they are asking us to calculate velocity and acceleration, and the maximum or minimum velocity and the corresponding displacement and the time at which the velocity is 0. So first of all, we have to find velocity and acceleration function. So differentiating with respect to t, we'll get the velocity function. ds by dt is nothing but velocity function, and that is equal to 3t square minus 6t plus 2. Then again differentiating with respect to t, we will get second order derivative of s, or you can say dv by dt, and that is nothing but equal to acceleration function, which is equal to what? 60 minus 6. Now next, find the velocity and acceleration after 4 seconds. The velocity and acceleration so time is mentioned, just क्या करना है, वैल्यू टाइम का 4 सेकेंड सब्स्टिट्यूट करना है वेलोसिटी फंक्शन में एज वेल एज एक्सेलरेशन फंक्शन में. सो वेलोसिटी at time t is equal to 4 seconds, it is equal to what? 3 into 4 square minus 6 into 4 plus 2. So it is 26 meter per second. The next acceleration at time t is equal to 4 seconds, and that is 60 minus 6, so 6 into 4 minus 6, which is equal to 18 meter per second square. Okay, next find करना है maximum and minimum velocity and the corresponding displacement. So what is maximum and minimum velocity? We know by the definition of derivative, application of derivative. Function is maximum or minimum where the derivative of that function is 0. So we have to compare the derivative equal to 0. So derivative of velocity is nothing but this acceleration function. So for maximum or minimum velocity, the derivative of velocity with respect to time is equal to 0, and that is acceleration is equal to 0. So acceleration 60 minus 6 is equal to 0. So 60 is equal to 6 and time t is equal to 1 second. Then the corresponding value of maximum velocity. So maximum or minimum whatever velocity. So v at this corresponding time is equal to what? Velocity function is 3t square minus 60. So 3t square minus 60 plus 2. So it is minus 1 meter per second. So velocity is minus 1 meter per second. Okay, at this particular point. And they are also asking the corresponding displacement. So at time t is equal to 1, what is the displacement s? So corresponding displacement at the point where velocity is maximum or minimum. T cube, that means 1 cube minus 3 into 2 t square, that is 1 square, plus 2 into t and plus 5. So they have not mentioned the corresponding displacement in the question bank. Okay, so it is one minus 3 plus 2 plus 5 is 5 meter. Okay, and last part is time at which velocity is 0. So just substitute velocity equal to 0. You will get to know the t, two values of t as the function of v is having second. This is basically a quadratic equation. So velocity, time at which velocity is 0. Time at which velocity is 0. So velocity is equal to 3t square minus 60 plus 2 and substitute equal to 0. So solve this equation. Three minus 6 plus 2, so it is 1.557. We will get one value as 1.577 second, and the other instant is 0.4226 seconds. So we have two values of time at which the velocity is 0. Pretty simple question. Just find, it is 4 2 3, both are correct. Some of the answers are not mentioned in your question bank, so please check. Okay, next question is again on the same topic, kinematics, where acceleration of the particle is given. The relation is given, A is equal to 25 minus 3x square, and it is mentioned that mm per second square. the particle starts with no velocity at the position x is equal to 0. So they have condition like no initial velocity at position x is equal to 0. Determine the velocity when x is equal to 2 mm, the position when the velocity is again 0, and the position where the velocity is maximum and the corresponding maximum velocity. So obviously, first of all, we have to find the velocity function and the position function, basically x is equal to from the given equation, but acceleration function is given. So can we use this formula? Acceleration function in terms of x is given, acceleration as a function of x. Can we use this formula? No. So we have to use another formula, which is equal to velocity dv by dx. So that is equal to 25 minus 3x square. Okay. So rearranging the term, v dv is equal to 25 minus 3x square into dx. Now integrating both sides, we'll get integration of v dv and integration of 25 minus 3x square with respect to x. So integration of this is v square by 2, then 25 into x minus x cube by 3 into 3 will get cancelled, and plus constant of integration c1, let's say. So there, for finding out value of c1, use this condition: particle starts with no velocity at the position x is equal to 0. So particle starts with no velocity. So x is equal to 0. V was also 0. So 0 equal to 25 into 0 minus 0. That means c1 is 0. So rewriting the above equation, v square by 2 is equal to 25x minus x cube. So you can write the function of v as v square is equal to 50x minus 2x cube, and therefore v is under root of 50 x minus 2x cube. So we have now velocity function v is equal to, so v is equal to under root of 50 x minus 2x cube. Okay. So first क्या find करना है? Velocity when x is equal to 2 mm. It's 9.165 is the calculated answer, and as it is given in mm, so obviously our answer will be in mm per second. The next, the position when velocity is again 0. So position when velocity is again 0. That means where the velocity is 0, what is the corresponding value of x? So substitute velocity equal to 0 and calculate the value of x. So 50x minus 2x cubed. Squaring both sides, you get 50x minus 2x cubed. You can take x common here, so 50 minus 2x square. So either x is equal to 0, but they have mentioned again. Again means not the initial condition. That means for velocity to again become 0, this value 50 minus 2x square should be equal to what? 0. So we already know x is equal to 0. They are asking us the another instant where the velocity is 0. So solve this. So 50 is equal to 2x square and 50 by 2 is equal to x square is equal to 25, and therefore x is equal to plus minus 5 mm. Then the position where the velocity is maximum and the corresponding maximum velocity. So next is condition position where the velocity is maximum and the corresponding maximum velocity. So third, where velocity equal to velocity max. So x is equal to value. So that means where derivative is 0. That means where the acceleration is 0, the velocity is maximum at the particular point where acceleration is given 25 minus 3x square. So 25 minus 3x square is equal to put 0. So therefore 25 is equal to 3x square. That means 25 divided by 3 is equal to x square. And that means x is equal to what? Under root of plus minus under root of 25 divided by 3. 2.88 7 mm. So plus minus we can say. We have two values, 2.887 . Okay. So Vmax is equal to what? So V function is 50 under root of 50x minus 2x cube. Put x equal to 2.887 . So this answer is 9.809 mm per second. Now what about the negative value? So if you put the negative value in the same equation, you will get infinity, right? That means can't solve. So that simply means for positive value of x, you will get the maximum velocity. So answer should be 2.887, which is correct. Max is also correct. So next question देखते हैं. A slider crank mechanism is shown in figure. The crank OA rotates anti-clockwise 100 radian per second, and find the angular velocity of rod AB and the velocity of slider at B. Okay. So this mechanism in which rod OA is rotating at 100 radian per second, and it is connected to rod AB, and AB is connected to slider B, right? So here we have to find the velocity of rod AB and the velocity of slider at B. So in order to solve this numerical, first we have to identify the motion. So AB is rotating, right? Is in rotating motion about OA is rotating about O in the anti-clockwise sense, and then this AB is connected to OA. As this OA is rotating in anti-clockwise sense, this will perform, AB will perform a general GP motion, right? Rotation as well as translation, and because of this AB rod is connected at B to this slider, so this block will also move. So this block B is performing translation motion, OA is performing rotation motion, and AB is performing general plane motion, which is a combination of rotation and translation. So first we have to identify that. Yes. So next we have to find the direction of motion. So we have identified this direction of motion, right? Then at particular point A, because of the rotation of OA, the velocity at this particular instant is in perpendicular to OA, velocity at A, right? In this is the direction of motion or direction of velocity, you can say. This is the direction of velocity B. This is the direction of velocity of A, and we have to find the instantaneous center of rotation for this particular rod AB, which is in general plane motion. So how we can find the velocity at this particular point is in horizontal direction, velocity at B, right? So draw perpendicular at B to the velocity. Okay. Then in the same way, draw perpendicular through point A. This intersection point is going to be instantaneous center of rotation. So as this OA is in anti-clockwise direction or sense, rotation of this OA is in anti-clockwise sense, this rod AB performs the general plane motion. The rotation will be about rotation will be in clockwise sense. Okay, so we have located the instantaneous center of rotation at this particular point I. Then we can use these angles. So if this is 20 degree, this should be 70 degree, right? This angle is given 40 degree, this angle is given 20 degree. So this angle here should be 120 degree, and if this is 120 degree, these OA and I, they are in the same line, so this should be 60 degree. And for this triangle ABI, if this is 60, this is 70, this angle should be equal to 50, correct? So we can use these to find the length of AB as well as the distance RAI, you can say, and RBI. So we can calculate the length of AB, RBI, RAI, but this is not a right angle triangle, so obviously we have to use sine rule here first. From this triangle OAB, we can find the length AB, and then ultimately from this triangle ABI, we can find RAI and RBI. So first find that values. This OA is 200 mm. That means 0.2 meter. So in triangle OAB, using sine rule, AB divided by sine 40 is equal to OA divided by sine 20. Okay, where OA is 0.2. So AB is 0.2 divided by sine 20 . Zero point 376 you can write. Then in this triangle ABI, using sine rule you can find RAI and RBI. So AB divided by sine of 50, that is equal to RAI divided by sine 70 and RBI divided by sine 60. So where AB is known, AB is 0.376. Now therefore RAI is equal to 0.376 divided by sine 50 or into sine 70. Then RAI is 0.4612 and RBI is equal to 0.376 divided by sine 50 into sine 60. Zero point 425. Okay, now we can find the value of angular velocity of AB. But before that, we have to find this velocity B, right? So how to find? We have this omega, right? OA. So velocity of point A, VA, is nothing but equal to this ROA, radial distance, into angular velocity of OA. So it is given 100 radian per second. Radian per second, and this distance is 0.2. So you'll get 20 meter per second, the value of velocity at point A. Now rod AB performs general plane motion where OA is in rotation motion, correct, and B is just sliding through horizontal plane. Now in order to calculate the angular velocity of rod AB, we can use the relation that this velocity VB is equal to RAI into angular velocity. So angular velocity of rod AB, which is performing general plane of motion. So omega AB we need to find, and we can use the relation VB is equal to RAI, where I is the instantaneous center of rotation for AB rod, and that is equal to VB is equal to RAI into omega angular velocity of rod AB, where RAI is 0.461, angular velocity is unknown, and velocity of point A actually VA, which is 20. So here we will get the angular velocity as 0.43 angular velocity 43.384 radian per second. Okay, and then we can also find the velocity of piston at B, VB, or velocity of slider at B, by using the same relation. We know V is equal to R omega, so VB is equal to R VI into omega AB, where R VI is 0.425 and omega AB is 43.384. .438 meter per second, and the answer given in your it is 18.44, so correct, right? So just look we have to find the location of this instantaneous center of rotation, right? Then on the same topic we have another question. That figure shows the collar A, collar B, which moves upward with a constant velocity of 1.5 meter per second. This is moving upward collar, obviously in the vertical direction, as it is restrained. The movement allowed is only along the rod in the vertical direction as given. So VB is 1.5. So what will happen if this B collar moves in the upward direction? Let's say here, so this rod will get displaced, right? So it will perform a general plane motion. So it slides along this inclined plane and it also rotates. There is rotation of AB as well. So that means it performs general plane motion as collar V slides in the upward direction. So they are asking us to find the angular velocity of rod AB, omega AB, which is pinned at B and freely resting at A, 25 degree sloping ground, and velocity of end A of the rod. So as this collar B moves, the AB rod is performing general plane motion. It tends to slide, the end A tends to slide on the inclined plane, and this B is pinned at the collar, so it will also rotate. So there is rotation as well. So first of all, we have to find the velocity of point A as well as the angular velocity of rod AB. Okay, so for that, first to locate the instantaneous center of rotation, this is the velocity, right? Velocity at point B. And obviously it will slide along the sloping plane. So velocity is direction of velocity of A is along the plane 25 degree with the horizontal. So first of all, draw perpendicular from A and again to the velocity component at B, draw perpendicular. So this should be the instantaneous center of rotation. Okay, so as this collar moves upward, this will perform general plane motion. The rotation will be in which sense? Anti-clockwise sense, right? So now first find the angles. Okay, so this plane is inclined at an angle 25 degree, right? And then this angle is given 50. So if I draw certain line, for example right angle triangle, so this total angle should be, if this is 90, this is 50, this total angle should be 40. And if this angle is 25, that simply means this angle should be 50. Okay, now this is the perpendicular, this is 15, so this angle should be 75, so that both the angles, addition of these angles 90. If this is 50, this should be 40. And now in this particular triangle ABI, if this is 75, this is 40, the remaining angle should be 65. So that the addition of these three angles of this triangle is 180. So I have located the instantaneous center of rotation. This is the angular velocity, let's say omega AB. Okay. So again, by using the same concept, we can find the rotation of this particular rod AB, angular velocity, and the velocity of end A. So let's find out. And the length of AB is given 1.2. This is 1.2 meter. Okay, so in triangle ABI, using sine rule, AB upon sine 65, then this distance will be RAI and RBI. So RAI divided by sine of 40, then RBI sine of 75. Okay, so we can find the value of RAI and RBI knowing the value of AB is 1.2. So RAI is equal to AB upon sine 65, which is 1.2 upon sine 65 into this sine 40, and RBI is equal to 1.2 sine 65 into sine 75. So RAI is 0.8511 meter, and one 1.28279 meter. Okay, now rod AB is performing general plane motion. Okay, so we have located the instantaneous center of rotation of rod AB. They are asking us to find velocity of end, angular velocity of rod AB. So how to find angular velocity of rod AB? We know VB, right? So VB is known, so we can use this distance RBI, and by knowing the relation V is equal to R, V is equal to R omega, we can find the angular velocity. So angular velocity of rod AB. So VB is equal to RBI into omega AB, and therefore omega AB is equal to what? VB upon RBI. VB is given 1.5 and RBI is 1.279. So 1.1728. Radian per second. Okay, now next, the velocity of end A of the rod. So velocity VA. How to find velocity? We have this again relation, V is equal to R omega. So we know omega AB, and then we can use that relation to find velocity of end A. So using relation, so velocity of end A is equal to RAI into omega AB. So RAI is 0.8511 and omega is 1.1728. (0.998) meter per second, which you can consider as 1 meter per second. Okay, so both are correct answers. Now last question. So in figure, Kolar C slides on a horizontal rod in the position shown. Rod AB is horizontal and angular velocity of the same is 0.6 radian per second clockwise. I determine the angular velocity of BC and velocity of Kolar C. Okay, so for this rod AB, angular velocity is given in clockwise sense 0.6 radian per second. Okay, so as this rod rotates about A, performing rotation motion, this BC will perform general plane motion because end C will slide along the horizontal rod, and this rod BC will perform rotation in the combination with the translation. So you can locate the instantaneous center of rotation by knowing the value of knowing the direction of velocity. So this is horizontal for this particular instant, and this is clockwise in sense the rotation of rod AB. So here velocity of B will be in this direction of velocity at B, and then because it rotates in the clockwise sense BC, this rod will perform this sleeve will slide along the horizontal rod in the right direction, or velocity will be towards right. Then the one value is unknown here is the distance, which is not mentioned in your question. It is 100. Okay, the distance between these 2 points. Okay, so what I'm going to do is just I can draw a perpendicular line through B to velocity at B and the same weight at velocity at C, and this is nothing but the corresponding instantaneous center of rotation, which will obviously rotate in which sense? Clockwise sense. So this is angular velocity BC. Okay, this is 90 degree. Okay, so next is the first they are asking us to calculate angular velocity of BC and velocity of color C, that means VC. So omega of angular velocity of AB is mentioned, which is 0.6 radian per second in clockwise sense, right? So rod AB performs rotation motion and it rotates about this point A. So instantaneous velocity you can find VB of B. This distance is RAB, which is equal to 140. So we can use the relation VB is equal to RAB to omega AB. So RAB is 140 mm into omega. 140 mm means 0.14 meter. Omega is 0.6 radian per second. So 0.084 meter per second. If you want to convert this into mm, so you have to multiply the value by 1000. So velocity of B is 84 mm per second. Now you can locate I by using the same. We have already located I. Now we can find the angular velocity of BC. Angular velocity of BC, we can use the relation same, V is equal to R omega, where VB for the GP motion is performed by rod BC. So we can use this relation VB is equal to R BI into omega angular velocity of rod BC. So rod BC performs GP motion. So for angular velocity of rod BC, we can use the relation V is equal to R omega. So velocity, instantaneous velocity at B is equal to RBI into omega BC. So omega BC is equal to what? VB upon RBI. Where from this RBI is 100 plus 140 240 mm, that means 0.24 meter. So 0.084 divided by 0.28 meter. Okay, 0.24 it is 0.35 radian per second, and we can use the value to calculate the velocity of the collar at C, that is BC. This distance is RCI, which is 180. So velocity of collar at C, VC. So VC is equal to RCI into omega BC. It is 180 mm, that means 0.18 meter, and angular velocity is 0.35. So it is 0.063 meter per second, which is 63 mm. You can write the same in mm as well, 63 mm per second. So likewise, you can solve the kinematics of rigid bodies just by understanding the motion of the connected bodies, and by using the simple relation and using sine rule as well. So this, we have calculated the velocity of point B as well as velocity of point C as well. Okay, so in the question they have mentioned angular velocity, but they have not mentioned the answer for angular velocity. They are mentioning the angle of they are mentioning the value of VB. Okay, so angular velocity of BC is not mentioned, and that is equal to 0.35. So likewise, you have to calculate. So in detail, if you want to learn the basics of engineering mechanics through scratch, you can join the crash course batches, which is starting from first week of December month. So please join. You can prepare for your semester exams. If you still have no idea about engineering mechanics, what are the various topics, and you are weak in engineering mechanics, you can join the crash course batch and you can easily pass your semester exam. Thank you.